When you look at the night sky, you're not just looking out into space. You're looking back in time. You're seeing a ghost. A beautiful, luminous memory. This is the story of that machine. It's a promise. A promise to answer some of the most profound questions we've ever dared to ask. To telescopes like our beloved Hubble, which sees mostly the light our own eyes can see, these are impenetrable walls. What if we had a kind of vision that could see through the storm? Its mission is to see in infrared light, what we often think of as heat. This is its superpower. The light from the most ancient objects in the universe has been stretched into the infrared by the expansion of space itself. It will analyze the atmospheres of distant exoplanets, sniffing the air, if you will, for the chemical signatures of water, of methane, of gases that might hint at the potential for life. This is a $10 billion gamble on human curiosity. So why do it? Why spend decades and a fortune to peer into the void? Because the story it is going to tell is our story. It's a journey to our cosmic origins. For decades, this has been our window to the cosmos. The Hubble Space Telescope. What if I told you this magnificent view was only showing us half the story? The universe has a night side, a hidden, shadowy world that holds the answers to our biggest questions. This is the genesis of the James Webb Space Telescope. As space stretches, the light wave stretches with it. Its wavelength gets longer and longer and longer. It's faded, exhausted. It's a ghost of its former self. Our universe is filled with cosmic fog, immense clouds of gas and dust that are the nurseries for new stars and planets. The dust itself is glowing. It's warm, and it's radiating infrared light. So, JWST is our ultimate night vision goggles. The solution? We had to build a giant that could fold itself up. Meet the Golden Eye, 18 separate segments, coated with a layer of gold so thin it's microscopic. Imagine taking a human hair and splitting it with 10,000 times. We had to make JWST colder than anything you have ever experienced. The answer was this: a sun shield the size of a tennis court. On one side, blistering heat. On the other, the deep freeze of space. JWST lives in that shadow. We sent it to a gravitational parking spot 1,000,000 miles away, a place called Lagrange Point 2. There are no do-overs, no space shuttle missions to fix a mistake. The entire, intricate ballet of unfolding was a series of 344 single-point failures. Every single one of those 344 steps was a white-knuckle moment. When that final mirror segment clicked into place, we had done it. We had built a new eye for humanity. So here it is, our time machine, deployed and perfectly chilled in the eternal shadow of its sun shield. That golden mirror is collecting whispers of ancient light. The mirror and the shield are the body of this observatory. But today, we're going to meet its heart and soul, the four incredible instruments that are the true eyes and ears of JWST. And the star of the show, the one that gives us those jaw-dropping pictures, is called NIRCam, the near-infrared camera. Its detectors are so sensitive, they could theoretically spot the heat signature of a bumblebee as far away as the moon. You know how if you block the bright sun with your thumb, you can suddenly see the world around you? A coronagraph does exactly that, but for stars. Without this, seeing an exoplanet directly would be like trying to see a firefly sitting right on the rim of a giant lighthouse. To truly know an object, we need to do more than see it. We need to take its fingerprint. NIRSpec doesn't just take pictures. It takes light and stretches it out into a rainbow, a spectrum. This is not just a picture. It is a portal, a single frame, captured in what we once thought was an empty patch of sky, now teeming with ancient islands of stars. The screen divides into four distinct, animated icons. JWST's entire mission rests on four pillars. Imagine the universe in its infancy, and then a spark. The very first star ignites. It's using NIRCam and NIRSpec to look for those first fledgling galaxies. JWST is like a cosmic historian, able to look at galaxies at every stage of cosmic history, all at once. This is where Miri, our cold vision expert, shines. When a planet passes in front of its star, JWST analyzes the starlight that filters through its atmosphere. It's looking for the barcodes of molecules, a spike for water vapor, a dip for carbon dioxide, a signature for methane. Finding them on a rocky world in the habitable zone would be one of the most profound discoveries in human history.